Hello class 12s, this is Pradhan. Okay, so this is my first ever attempt, okay, for an online class, and the topic that we are going to start with is capacitors. I believe this is the last topic that we are discussing. Alright, so don't forget, a capacitor is an arrangement to store large amount of charges. Okay, but before we actually strictly jump into capacitors, let me talk about conductors. Okay, we have a conductor. Say for example, we have a plate. Now we know that any conductor will have its own capacitance. All right, the ability to hold charges. Any conductor will have it. Obviously, the greater the size of the conductor, the more will be its capacity, that is its capacitance. All right, what I've written on this page is, the factors on which capacitance of a conductor depends. Now I've written down three factors. One of the factors is surface area or the size of the conductor. Of course, greater the size of the conductor or the surface area of the conductor, all right, more will be its capacitance. Then the presence of other conductors in the vicinity. We are going to see, how the presence of other conductors affects or influences the capacitance of a particular conductor. All right. Then after, the third thing is presence of a dielectric medium. Now this particular thing we are going to keep it on hold right now. The third point, we are going to keep it on hold. Don't forget, let me tell you what a dielectric means. Dielectric means an insulator. Dielectric is simply an insulator, remember. Okay, we are going to talk about the third point. All right, but we'll keep this on hold. Okay, in the classes to follow, we are going to discuss this particular point. Today, what I'm going to actually discuss, this video actually is for the second point. That is the presence of other conductors in the vicinity, how it affects the capacitance of a conductor. All right, now, so coming back to our plate here, conductor, this conductor, say for example, we give it positive charges. This particular conductor, we give it positive charges, and say for example it reaches its full capacity. All right, now what we do is we bring another conductor in its vicinity. Say for example another charged conducting plate. It could be anything, it could be any kind of a conductor. All right, but today for now I've brought a plate, okay, a conducting plate. Now this particular plate is neutral. We haven't given it any charge, remember. Okay, so this particular plate is neutral. Now what happens, okay, let me just draw these two plates as two lines. Okay, so this particular conductor, this is the thing. Okay, so this has positive charges. This has been given positive charges, and we bring another neutral conductor, another neutral plate, conducting plate in its vicinity. All right, now what happens is you all know induction. Okay, so due to this positive charges, what happens is negative charges gets induced on the inner side of the plate. On this side of the plate, what we have is we have negative charges getting induced, and on the farther side, on the outside of the plate, the second plate, on the outside of the plate, what we have is we will have positive charges. So on the inner side of this plate, the second plate, which was actually neutral, okay, still right now it's still neutral, okay, because this equal amount of positive charges and equal amount of negative charges we have, and they cancel each other. So the overall amount of charges on this plate is still 0. So this plate is still neutral. All right, but what happens is on the inner side of the plate we have negative charges, and on the outer side of the plate we have positive charges. Now what happens is if we connect this second plate to the earth, that is the ground. All right, now this is the symbol for ground connection, either this, I hope it's coming on the video. All right, so either this or you have this picture, this symbol for ground connection, earth connection. This means simply connecting it to the earth. Okay, now once we connect it to the ground, what happens is these positive charges on the outside of the plate, these positive charges, they simply flow to the earth, they simply flow to the ground, they are kind of attracted by the ground. All right, whereas these negative charges on the inner side of the plate, they do not move to the ground. Now I'll tell you the reason why they do not move to the ground. Okay, so after these positive charges they move to the ground, the scenario is something like this. So you have positive charges on the first plate, and you have negative charges. Now you only have negative charges on the second plate, no positive charges on the second plate. Okay, now why is that so? Okay, now before I tell you the reason, let me tell you the charges that the positive charges, these positive charges that are induced on the outside of the second plate, these positive charges are called, these are called free charges. These are called free charges. And these negative charges that are induced on the inner side of the plate, they are called bound charges. What's the spelling of bound? Bound. Okay, bound charges. Okay. All right. Now, why are they called free charges? Why are they free charges? They are free charges because, remember, these positive charges, they are kind of repelled by the positive charges on the first plate. The positive charges on the first plate, they want to repel these positive charges. That is why these positive charges, they actually being repelled by the positive charges on the first plate. Okay, they move to the ground. And the negative charges on the inner side of the plate, they are called bound charges because these negative charges are bound to these positive charges. These positive charges are trying to pull the negative charges. So therefore these negative charges are as if they are held by the positive charge on the first plate. So therefore these are called bound charges. Now if you don't understand, okay, you can leave a comment, all right, or you can replay the video again and listen to my words again, all right, explanation again regarding this. So remember, now what we have is, we have positive charges over here on the first plate, and we have negative charge. We are left with negative charges on the second plate. Okay, remember, the negative charges, they do not flow to the ground. Even if the second plate is still connected to the ground, they do not flow to the ground. Okay, now what happens after this case? All right, what happens after this? Let's try understanding it. Okay, so what happens is, these negative charges, the bound charges, they kind of, see, before we brought this neutral plate, before we brought this second plate, okay, the positive charges, the first plate had reached its capacity, full capacity, such that it could now accept no further amount of charges. So it had reached its capacity. Now, after we have negative charges on the second plate, these negative charges, what it does is, these negative charges, they try to decrease the influence of the positive charges on the first plate. Decrease the influence in the sense, what happens is, these negative charges, they try to negate or cancel the effect of the positive charges. They want to lower the influence or effect of the positive charges on the first plate. All right, such that what happens is, due to these negative charges, the potential of the first plate decreases due to the presence of the negative charges. Now, once the potential of the first plate decreases, we can further add some amount of charges to the first plate. Had this negative plate not been there, the positive plate had already reached its capacity. This thing had already reached its capacity. All right, but since we have a negatively charged plate in its vicinity, these negative charges, it tries to decrease the influence of the positive charges. Because if, say for example, the negative and positive, they meet each other, okay, we get a zero. So it's like when they meet, the negative charges totally cancels the effect of the positive charge, because you get a zero when these two charges meet. But here these two are not meeting, remember, these two are not actually meeting, but they are very close to each other. But still, they are very close to each other, so therefore these negative charges, that is why I'm saying these negative charges, they try to cancel or decrease the effect of the positive charges. Okay, so once the effect of the positive charges decreases, okay, it's like the number of positive charges is decreasing on the positive plate, on the first plate, due to these negative charges in the surroundings. All right, so since the influence of the positive charges are decreasing, what happens is the potential of the first plate decreases, because we know charge is directly proportional to potential. The more the charge, the more the potential. The lesser the charge, the lesser the potential. No charge, no potential, of course. Okay, so since the effect of the positive charge is decreasing due to the negative charges, the potential, it's like the positive charge, it's like, only like, that the positive charges are decreasing on the first plate, so therefore the potential of the first plate decreases. Okay, now once the potential of the first plate decreases, remember, we can add further amount of charges on the first plate. So therefore this first plate can now accept extra amount of charges or large amount of charges than in the case when it was all alone. All right, so due to the presence of a conductor, this is how a given conductor can hold more amount of charges. Okay, all right, and this particular arrangement, which can hold large amount of charges, is what is called a capacitor. Okay, and this in particular over here is what is called a parallel plate capacitor, which is there in your syllabus. Okay, we are going to discuss this more about this in the other video lessons. Okay, this is my very first attempt. Okay, any problems you've had, you can write it down in the comments. All right, or you can let me know about it in WhatsApp itself. Okay, all right, so stay at home and stay safe. Okay, these are very difficult times, so stay at home, stay safe, and take care of yourselves. Thank you.